Hello everyone, welcome to my channel. You are learning with Dr. Shobha Nikam. In this video, we will talk about the acceptance angle, the critical angle, numerical aperture of the fiber and the acceptance cone. Before that, you must know how light ray travels through an optical fiber. In optical fiber communication, we send our information over optical signal and optical signal travels through optical fiber's core. So basic structure of optical fiber is it has core and this core is covered by the cladding. So light ray travels through this core material by total internal reflection. So you must know how this total internal reflection occurs. You all are aware of two phenomena, refraction of the light and reflection of the light. So refraction is, see, there is some refractive index for core, there is some refractive index for cladding N1 and N2. You need to remember in optical fiber communication, always refractive index of core is greater than that of cladding's refractive index. So that it means core is much more denser than that of cladding. So when light ray enters into optical fiber, when it enters through the optical fiber, it makes some angle with the vertical axis. So this is θ1, the angle made by light ray with the vertical axis. Then when light ray enters into the fiber, it goes into the cladding material or less denser material, or we can call it as refraction of light. Light ray refracts, it enters from one material into another material and it makes angle theta, or we can call it as θ2 with the vertical axis. Then when we keep on increasing this incident angle of incidence, then at one particular value of incidence angle, the light ray does not enter into another material, but it travels over the core cladding interference, or we can say it makes 90 degrees angle. This angle is 90 degrees. It makes 90 degrees angle with the vertical axis, and this is called as critical angle. Critical angle of incidence when light ray makes 90 degrees angle with the vertical axis. When we increase our incidence angle further, here you can see this is less than critical angle. Angle of incidence is less than critical angle. Here it is same as critical angle. And when we further increase angle of incidence, instead of refraction, instead of light ray entering into another material, it reflects back into the same material, and this is called as total internal reflection, and we need this total internal reflection to travel signal from the source end to the receiver end. So condition for total internal reflection or to travel information from one place to another place in fiber optic cable is our angle of incidence must be greater than that of critical angle. Now we know the condition that angle of incidence must be greater than that of critical angle. Now we must know what is acceptance angle. So acceptance angle, or this here I have drawn a cone. This is called as acceptance cone. So acceptance cone means light ray, when light ray enters through this cone, it means it can make any angle with this line. So with this axis of the fiber, see, this is my fiber, this is my core, and this outer is my cladding. And you can see here light ray is not entering into the cladding. Instead of that, it is traveling through core material only. Refractive index of core is N1, refractive index of cladding is N2. So when light ray falls in this acceptance cone, this is called as angle of acceptance. So light ray makes it is the maximum angle. Acceptance angle is the maximum angle with the axis of the fiber. So if my light ray will fall outside of this cone, if my light ray will make angle more than that of this angle of acceptance angle, then instead of total internal reflection, light ray will enter into cladding material, and this is called as lost ray. So angle of acceptance is the maximum angle made by light ray with axis of the fiber. Then there are axial rays. Axial rays means instead of this total internal reflection, light ray travels over the axis of the fiber. So this is called as axial ray. Then there is a meridional ray. So meridional ray pass through the meridional plane of the fiber. So this is called as meridional ray. Then comes skew rays. There are skew rays. So skew rays travels through optical fiber only, but they tries to follow helical path. So it is difficult to track their path because they do not lie in single plane. Skew rays. So there are axial rays which travels over the axis of the fiber. There are meridional rays. So these are meridional rays which travels because of total internal reflection, and then there are skew rays. Skew rays also travel because of total internal reflection. Only the thing is they follow helical path. Then comes acceptance angle. So it is maximum angle with the axis. If light ray will make more angle than acceptance angle, then it will not travel through the core. Rather it will get lost into the cladding material. Then comes numerical aperture. So numerical aperture is sign of maximum angle that an incident ray makes with core axis and travels the core using total internal reflection. Now see, formula for numerical aperture is, there are multiple formulas. So one formula is under root of n1 square minus n2 square. Here n1 is refractive index of core and n2 is refractive index of cladding. Another formula is numerical aperture is equals to n1 under root 2 delta. Delta stands for relative refractive index difference. Then phi c is critical angle. Critical angle at which our reflected ray is parallel to core cladding interface. So it is sine inverse n2 by n1. So the condition is our angle of incidence must be greater than that of critical angle. So we must know what critical angle is. Then this is zeta. So it is, if angle is small, it is related with solid angle and it is denoted by zeta, and formula for zeta is pi in bracket Na square. Now let's see some numericals based on this topic. So I have taken an example. Step index fiber has relative refractive index of 1.3. So relative refractive index means what? It is delta. Delta is given as 1.3%. Core refractive index is given as 1.5. It means N1 is given as 1.5. Wavelength is denoted with lambda. So lambda is given as 850 nanometer. Assuming fiber is kept in air, calculate numerical aperture, angle of acceptance and critical angle. Now let's revise the formulas. So see, given data is delta is given, N1 is also given. By putting these two values here, we will be able to calculate our numerical aperture. So first, delta is given in the form of percentage. We will convert it. Delta is equal to 1.3%. So it is 1.3 divided by 100. So it will become 0.013. So Na we can calculate it as N1, that is 1.5 under root 2 times 0.013. And if you will calculate this, it will become 0.244. 4. So our numerical aperture is 0.244. Next is angle of acceptance, theta A. So theta A is equals to sine inverse of numerical aperture. Now we have value of numerical aperture. By substituting this value, sine inverse of 0.244, angle of acceptance becomes 14.12 degrees. Theta A. Now we have value of acceptance angle also. Next thing is calculation of critical angle, so that we can keep our incidence angle more than that critical angle. So critical angle is represented using phi c sine inverse of n2 divided by n1, but we don't, the value of n2 is not given. So by putting our values here, delta is given, n1 is given. So by substituting value of delta and n1 here, we can calculate value of n2. So I'll calculate n2 first. Delta is equals to n1 minus n2 divided by n1. So it will become n2 is equals to n1 minus delta times n1. This n1 will come to this side and it will become delta into n1. And then we'll take n2 this side and this value this side. So it will become n2 is equals to n1 minus delta n1. So by putting these values, we will get n2 as 1.48. Now we have value of n2, we have value of n1, we can calculate critical angle. Sine inverse of 1.48 divided by 1.5, and you will get critical angle as 80.63 degrees. So in this way we can calculate value of numerical aperture, value of acceptance angle and critical angles. Here the relative refractive index difference is given, delta. Sometimes the case is, it may be like n1 is given, n2 is given. So you just need to remember these formula. Relative refractive index difference is n1 minus n2 divided by n1. Phi is sine inverse of n2 by n1. This is phi c, critical angle. Sine inverse of n2 by n1. Angle of acceptance is sine inverse of numerical aperture. So in this way we can calculate the values. So in this video we discussed about the total internal reflection, angle of acceptance, acceptance cone, axial ray, meridional rays, Q rays, and then we also discussed, we checked the formula, the numerical based on these variables. If you found this video, do like, share it with your friends and subscribe to my channel. Thank you for watching.